size of cation, how it's getting smaller than the corresponding atom. This is for cation which is has charge. For example, Na plus is much more smaller than Na because we're going to reduce one of the electrons, so it's getting shrink. Okay. Alright, then the attraction between the nucleus going to be big, but the size going to be lower. Okay. For anion, the other round of cases where Cl minus means that it's going to attract more electron towards it. So it has bigger size, alright, and then compared to Cl. So this is a summarized. Positive ion are always smaller than the atom, and then negative ion are always larger than the atom which they are formed. So we go with isoelectronic. Isoelectronics, iso means same. Electronics, yes, electronic number. Alright, so series of ions or atoms which have same number of the electrons, the size of ion decrease as the number of proton increase. Alright, so reason is much more higher nuclear charge of proton are pulling in the same number of electron. The larger number of electron, greater repulsion between the electron, the larger ionic atomic radius. Okay, just look at this one. This is 10 electron series where we have neon and A plus means that you reduce one of the electron, it becomes 10. Mg2 plus is become 10 again. So aluminium, you reduce 3 electrons, it become the 10 again. Alright, so this is isoelectron. They have the similar number of electron, but who is bigger than who? So you have to look at the charge. Okay, who is have more charge will be smaller one. Right, so means neon is the biggest one compared to Na plus. This is going to be reduced one of the size. It's going to be reduced 2 of the size. Magnesium is going to reduce 3 of electrons. So magnesium is bigger than aluminium. Right, so can we rank this? Alright, so I want you to do this exercise. Usually using only periodic table, rank each set of main group element in order of decreasing atomic number. So we have calcium, magnesium and strontium. This is all from group 2. As we goes down to the group, what will happen? Right. The element decrease in size as you increase in size as you go down the group, but decrease in size as you across the period. Alright, okay. So strontium is much more bigger than calcium. Calcium is bigger than magnesium. This is in group 2. How about group 1? Calcium much more larger than Ca, much more larger than Ga. This is in group 4. And then C. That's the answer. And then D. Okay. Alright. Now we determine in terms of decreasing size. Alright, so look at the charge. Who is bigger than who is lesser than who. This one you have to determine according to the period or the down the group. Alright. Okay, due to gain or loss of electron. Alright, so strontium, for example, strontium 2 plus is much more higher than Ca2 plus. Ca2 plus is much more higher than magnesium 2 plus. They are group 2, but decreasing in size as goes up to the group. Okay. Alright, so the rest you may look at this. This is isoelectronic where they have same number of electrons. Right? Okay. So next we go with ionization energy. Ionization energy is energy needed to remove 1 mole of the outermost electron from 1 mole of neutral atom in gas phase. Right. So for example, this one magnesium to magnesium plus, sorry, Mg plus Mg to Mg M to M plus. Alright, here you lost one of the electron, or M plus to M2 plus, you lost another 1 electron. Okay, it could be, this is called as second ionization energy. This is first ionization energy. You just draw one of the electron. This one you withdraw 2 electron. Alright, so factor the effect ionization energy is atomic radius, nuclear charge, also screen effect. So atomic radius increase from outer electron, atom increase, okay, ionization decrease. Okay, so this is a distant outer electron from the nucleus increase, right? So nuclear charge become more positive, attraction of the outer shell electron increase, cause ionization energy increase. Screening effect means the repulsion effect. Okay. Alright, so its effect on inner shell, it has stronger, lower quantum number have stronger shielded effect. Radius of the positive ion is smaller than atom. Attraction between nucleus and electron less stronger. Screening effect. Okay, so it's increased from first ionization, second ionization to third of. Okay, argon is on the right. Okay, so goes up to the. Okay, so you have to memorize that one. Okay. So first ionization of group 3, for example, boron, are smaller than group 2A, for example, beryllium. The reason is because electrons are more difficult to remove from complete orbitals such as ns2 and sp6. Okay. Look at this one. Look at how many electron configuration. For beryllium, we have helium 2s2, boron, helium 2s2, 2p1. This one you have one extra electron that easily to be removed. But for beryllium, we have 2s2, which is much more stable and it complete. So each have what we call ionization energy of this one is much more higher compared to boron. Boron is much more smaller. Alright, much more smaller because this one will be reduced. Alright, and then group first ionization of group 6, for example, oxygen are smaller than group 5A atom, which is nitrogen. Because of this one, electrons are more difficult to remove from half complete orbitals such as N2, NS2, and D5. Okay, for example, this one, nitrogen. Okay, nitrogen is much more difficult because it has 2p2. Each orbital is complete, even though there has only one electron each room. Alright, for this one, 2p4, we have one extra. Okay, one extra. Okay, and then the rest doesn't have pair. So this one is called as non-complete. Alright. So much more easy to remove oxygen compared to nitrogen. So that's why ionization in nitrogen in oxygen is much more smaller compared to. Okay. Alright, so you can do this exercise, how to rank the ionization energy. So next is electron affinity. Electron affinity is ability to gain one mole of neutral atom in a gas phase. For example, this one is like a contrast with the electron ionization energy just now. This one, how able you are to receive the electron, okay, from 1 mole of neutral atom, right? So the addition of one electron to neutral atom is exothermic, so that's why you got this value. Okay, when an electron is more easily accepted into an atom, more atom is given off, thus higher energy. So this is electron affinity of the group. Okay, general trend, electron affinity become less negative or decrease downwards in the periodic table. So electrons are added less easily into the atom because increase of size. Electron become more negative towards the right. Okay, the reason electron are added more easily. Okay. Right, so this is what you have to remember about this one. Right, so this one is increased, the one is increased to the right. So electronegativity is ability of atom in a covalent bond to attract pairs. Alright, to share the electron itself. The higher electronegativity of the atom, the greater is attracted the bonding electrons. Normally, elements that have low IE, ionization energy, have low electronegativity as well. There are like what we call correspond to each other. Okay. Element with high ionization have high electron. So, alright. So this is a summary of physical properties. Atomic radius when it comes from left to right is decreased, but from top to bottom is increased. Just atomic radius will be increased. Just remember that the rest will be decreased. Alright, and then this one atomic radius just will be left to right will be decrease, but the rest will be in increase. Okay. Alright, so this is how you're going to remember this. So that